very old computer by computer age. We talk about dogs and dogs' ages compared to humans. This is an ancient computer by computer age. Oh, I'm sorry. I can use this. Maybe it's easier if I use this. Thank you. Okay. Thank you again for the opportunity to come and join and continue our conversation from yesterday. I will try to refer only very briefly to some of the things I mentioned yesterday, but I think that the context will be clear enough that that won't cause too much confusion. What I'm interested in, which I mentioned only in passing yesterday, is the relationship of models, how we think about complex phenomena. And by complex, I don't mean complicated. I don't mean lots of parts that have a linear relationship to one another. So you can look at an automobile engine, or a bicycle gears, or something else that's actually quite complicated, but it actually has a very simple, in a sense, very linear relationship between one part and another. So the gear moves and another gear moves. And you can understand the relationship even if there are 20 gears. It takes a little work, but you can understand it. Problem comes when those couplings, when the relationship is no longer linear. So that a small change in one component has a very big change somewhere else. And talk more about that. But so models are an important part. But the other part that's enormously important and that we've been talking about in a way here is the idea of narratives, of how we tell stories. How do people understand what we're talking about? Well, human beings, as long as we know anything about them in terms of history, have told stories, made paintings, danced, sang. Why? One way is that it's a very powerful way to remember things, critical things, in a very tight encapsulation. So we've told sagas, we've told stories, we've written, because they have enormous emotional resonance. They really capture us. And we keep those in our mind. In a sense, we perpetuate culture with this in an oral way, and now, much more recently, in a written form. So what I'm really talking about, to follow on from yesterday, is living in the Anthropocene and dealing with models and thinking about how do we get to a new narrative for sustainability. And I'll talk briefly about different functions and forms of models, and going from models to narratives, a little bit about narratives, and then something about what I'd like to do with that. So in the interest of a short time, I'm going to jump several steps, but please let me know if something isn't clear, or we'll take it up in discussion later. So as I showed yesterday, in the Knowledge, Learning, and Societal Change program that we're putting together, this 10-year program with several projects within it, the key idea is that in the center of what we're looking for is humanity and the social and economic and ecological systems that couple then to this whole system. But the minute we start talking about the human, social, and economic system, already we've got a complex system. Now couple that complexity to the outside complexity of these feedback loops, then you have something very complicated. And then the question is, it's not only complicated, it's complex, because it interacts in many different ways at different levels. And one important point that I just want to point out here, I'll use this so I can stand over here. In a sense, these are boxes, but they also can be thought of, when I talk about models in a moment, as kind of stocks. There's a certain amount of pollutants here,
there's a marine system here and it has different things in it. And when I talk later about stocks and flows, I mean that there are things in this box and some of them move by flow to another box and vice versa. So just to use that as a reference point. Then, why do we need models? Well, oops, is this on? Yeah. I'm not sure. You know, maybe it's clear if I'll go back to this and I can point. Is this? Yeah, it is. Good. Sorry. We don't need to read the whole thing. The point is that Paul Krugman, a Nobel Prize-winning economist who writes rather wonderful articles in the New York Times, opinion pieces, talks about the fact that the Wall Street Journal, of all places, it doesn't think that complex models are important, that just the way you feel about it should be enough. We don't need fancy theories or models, in effect, to solve problems. We just, how do you feel about it? Well, that's obviously totally inadequate. And we need the models, both formal ones and mental ones, to effectively address complex systems. And I loved this, and I can't resist putting it on. There are two cows talking to each other. And if you remember, cows have 4 stomachs. And in English, we have the expression, gut feeling, your intuition. So one cow says to the other, I can't decide anything. I want to follow my intuition, but it's confusing. I have 4 different gut feelings. So, in fact, it's really not it's not something that we can deal with in complexity. So let me talk very briefly, and I'll make this very condensed, but just to point out in very general terms, there are sort of 3 fundamental kind of forms of models. First of all, what is a model? It's really a way of thinking about a system that is more complex than we can keep in our short-term memory. So we do it because we have to make an approximation. We cannot actually work with the real thing. And you think, oh, okay, that's, mathematical, whatever. If I take an object, and I decide to take this object and throw it, right as soon as I did it, Professor Tsai got ready to catch it. And if I throw something to a little child, even a few months, maybe 8, 9 months old already, from experience, they already have a model in their mind that their hands have to go somewhere. And as we get older, of course, that model is refined. We're not calculating the trajectory. But we do have a model of what that is, and there are different ways that we do that. And that's also a model. But there are also models, more involved versions, but if we stay with the mental models, the heuristics, they are just quick ways to make a decision about something or to evaluate it. Sometimes it's just that I'm going to buy this product because that's the last one I saw advertised. So it's the last thing in my head, and I can't remember all the other brands. But oh yes, I remember that one. And there are many versions of this. More important from our point of view, from my point of view in terms of thinking about models of complex systems, are either system dynamic or agent-based models. And virtually all other models fall into one or the other of those 2 forms. That is, one is a mathematical construct. It uses analytic methodologies of mathematics to describe what I showed earlier, these stock and flows. That is, that can be a biological system. So if I give you a drug for some illness, how long does that drug stay in the body? In what parts of the body? How does it move through different organs in the body, as an example? And there are quite elaborate mathematical models for doing that. Some of those models use primarily differential equations, but also can be computed by difference equations. Another category of models are agent-based models, where you describe a way, an agent is any subset here, and the agent acts in a certain way, and you give it rules. And the agent could be, each of us in this room is an agent, and then we describe how we relate to each other in some way, or it could be a bank interacting with another bank, or any other institution to institution. And when that's done, this is described with a set of actually relatively simple computational relationships. But because they are coupled in many ways and nonlinearly, things emerge from looking at this pattern that we wouldn't otherwise see. So we begin to see emerging patterns of interaction that we did not write down in the rules. So we wrote the rules, but once those rules are in effect, then things get complicated. Just as you know, when you get a whole room full of people, you're not quite sure what's going to happen when something comes up, if there's a controversial issue, whatever. So modeling is a very fundamental process for humanity. The problem is, in education, we never talk about models, really. We teach people with the results of the models, but we don't tell them where it came from. And the fact that they're limited as approximations. They are not the truth. They're the best shot we have at the moment, or successive shot. So we can teach classical mechanics, and it's pretty good. But we need to also teach then, at some point, if you're interested in doing the physics, quantum mechanics gets a little better model for some cases. Some cases it doesn't matter. Classic's fine. But models also are something that we don't teach, and I just give you a quick example. I just did this last week in Nanjing with a bunch of students. The frozen bubble box, which is just dry ice in the bottom of a transparent box, and soap bubbles. And we can do physics, chemistry, biology, global warming, carbon sequestration, all kinds of things can be explored with this very simple system. But the point of it is not to teach pieces of information. The point is to provoke, because it's such a surprising thing. For example, you blow a soap bubble into this box, and the soap bubble doesn't fall. It sits there. And if you can see the women's faces here, or the children's faces there, regardless of culture or age, the reaction is, oh. And then, what's most important is that that provokes the questions. Then we can start a real conversation. I don't answer questions when I'm doing this. I help them find ways to test whether their idea works. So why do the bubbles float? How do we test that? How do we find out what's inside that box? I don't tell them, we work on it. We figure it out by doing experiments. What I often get is comments from people say, well, young children can't understand this. My answer is, yes, they can, and they should. One example, I don't have time to go into more, but one example is you walk into a second grade classroom and you ask the children, where's somebody from another class going to sit in the lunchroom today, or on the school bus, or in the auditorium, or whatever the right circumstance is. And they say, how do I know? What are they going to do? Well, let's draw a little diagram of the room, and here's the door, and what kind of decisions might you make? Well, usually there's this lunchroom teacher, and she's really mean. You don't want to be near her. Oh, okay, so she's over here, I'm going to be over here. Oh, but there's this kid I really want to sit next to, and he's over here, so where's the best? Okay. So we end up making a decision tree, and you've made a model, and you can put it on, with NetLogo, you can very easily put it on a computer animation. And what's more, and really important, we can go down to the lunchroom and test it. And they think this is hilarious. They love it. But then once you've done that, you can begin to increase the complexity of these models. You also are doing something that is non-disciplinary. You can solve problems regardless of what topic it's supposed to be about. It's about figuring out what you need to understand and how do you make the model and how do you test the model in a direct way. So the point is to look at models as a way of systematic consideration of options for decisions. They're not answers. They give us a set of options, but they depend on the assumptions, on the question that is asked in creating the model, and on the data and the commensurateness of that data. We need to have a way of integrating modeling in curricula and using it to really build problem-based, transdisciplinary project learning. Much more can be said about this. Computational modeling is very important because you don't need much mathematics at all to do it. You can do it in a progressive level from second grade or even first grade on. You can use games and simulations, which after all are models. I mean, they're based on models. And we can use them, and they can be used quite powerfully. And it can be done at all levels of education and in informal venues, in school, in museums, in science events, in parks, in shopping malls, whatever you'd like. I will very quickly just mention, because I'm out of time, that there are a whole set of projects that I'm involved with that are examples of addressing models. And I don't have time to go into this now. I mentioned this one where we're looking at heuristics yesterday in local situations, but questions about how people think about real problems in their communities. What are their models and how do those translate into choices of action in the community? Just briefly to go there. And last thing I want to mention is the idea that narratives are the way we tell these stories, as I said. So they have affect, emotional content, and they're an opening for empathy, for caring about someone else. It's not the science content that makes people care. It's the relational aspects of trust and care that matter. It's effective in the sense that it is memorable and it can be communicated widely and easily, and it's also a way to reflect on our experiences. And they can be created, and I don't have time to talk about this, but the idea of creating narratives through effective collaborations between social scientists, natural scientists, technologists, humanities scholars, legal, historical, psychology, a whole range of things, and artists and designers, to catalyze this development of new narratives, and then also, equally important, to understand how can we assess the impact in different cultures in different ways. Let me stop there for lack of time. By the way, afterwards you can come and play with something and figure out a model of what's going on.
Okay, we have a little more than 20 minutes for discussion. Our speaker gave a very good introduction to start this open section. So, which person want to start this discussion? So, I would like to invite all three speakers so the audience will maybe ask us questions you can answer.
We can move the name tags. Good.
I think if I will take the privilege to start asking a question because I'm the chair in this section. And as you know, there's a great uncertainty on projecting the future climate change. And I believe most people in this room is climate change believers. But we know there's a, you know, the climate change is whether it's the anthropogenic, there's a human-induced or nature-induced changes is debatable. So I just want to ask all three of you, what's your opinion on this? Because your talk is based on the climate change, mainly is induced by humans.
I'll just, well, I mean, my take on that, I mean, part of it, there's a lot of talk about belief. Yes, there's belief and there's deniers, but for me, it's sad that there are so many deniers of anthropogenic climate changes. Even if we don't know the exact numbers, we do know roughly how much carbon we are letting out and how much we have historically, at least roughly. And we know enough, thanks to the climatologists and geoscientists, that this has an impact on climate change. And so to say that, well, we don't know everything right down to the 5th decimal point, and so we can't say anything, is absurd. Of course we can say something. We can't answer all the questions about it, but there is that anthropogenic climate change, and even if we can't distinguish it entirely from what would have happened otherwise, some sort of counterfactual development that would have taken place had we not, had industrialization or whatnot. And I think we know enough which doesn't mean that we shouldn't keep trying to learn more, but for me, it's not so much a question of believing or denying. I mean, we need to take what we know, be critical of what we know, and pose important questions based on that. And so if you want to know whether I'm a believer in anthropogenic climate change, yes, but I see it as a little bit more than a question of belief.
Well, I would approach it essentially in the same way that I just was talking about, namely that on one hand, in order to make sense of ideas about climate change or any of the other complex issues, people have to at least have a sense of what we mean by models. And what they're asking sometimes in the denial is, well, but that's just a model. Well, sorry, but that's exactly what we have to think about lots of issues. And just because it's become sort of a big debate doesn't make it any more possible to function without the model. It does have, science always has uncertainty in it because it's evolving, it's changing, and it must, and it should. But the other side of that is the narrative. And in many cases, the denial has nothing to do with the content of the science. It has to do with identities of people, the way they believe, for many reasons, about how they are related to the world and to their community. So that in many cases, this is seen as very threatening, the idea of climate change and of having to change one's patterns of life because of that. So I think it is dangerous in a way for us, if you will, to hide in an ivory tower of intellectual effort around the models without also addressing how we communicate. And by doing that, again, not simply by hitting people over the head harder with more facts and more science, but rather of trying to understand the kinds of emotional, community-related, relational, trust, confidence issues that they are actually responding to. And if one hears, unfortunately, some of the right-wing ranting and raving that goes on, for example, in the US, it's appalling, but that doesn't make it go away. We have to understand it in order to be able to address it with new narratives.
I really hope we're wrong. I really do, but I don't think we are. I'm a believer in insurance. I don't know if my house is going to burn, but I have insurance. And so I think that what we need to do is to be practical about it. The climate is changing, and it has always changed, but it has never changed at the speed that it's changing, and it's never changed with 7 billion people here on the planet who think they own land. So there could be huge consequences. So from an insurance point of view, what would be wrong if we do try to act and we find out that it wasn't really happening? As opposed to what would be wrong if we didn't act and it did happen. So I think we need to look at that matrix of it's real and it's anthropocentric, or it's not. We act and we don't act. Fill in those 4 squares, and I think you'll see that we should act.
So, please.
I think I may share some experiment about my scientific research. Because in Taiwan we have the problem of the urbanization, so the regional or local climate may be changed a lot. If in specific region like in Taipei, and respect the records for 100 years, maybe the temperature increased 2 degrees. I think that's the increasing trend is much more than other regions. And even the Salmon Lake, the average temperature is, it didn't increase too much. But I think the information may be not too many audience want to listen, because they fear we still have very cold winter. If some winters have some snow occur like the 2008 in China, we face a snowstorm. So it's very difficult to explain to our audience what happened to the world. So do you have any ideas if you have some cold winter occurs, and how can you convince your audience?
Okay, let's jump in.
Just maybe a very quick response to it. I think this is an interesting issue, again, of how we communicate. And one of the problems was that this started out around global warming. And right away people said, well, but it didn't get warmer. You know, it must not be right. Well, part of the point is that it's a change in conditions which also lead to instabilities and to localization. The average temperature may go up, but people may not experience that, and they base it on their own experience. So we have to be very careful about sort of how we describe that, and what it is that we use, the kinds of metaphors and the kinds of descriptions that we use for what we think is going on. And we can very easily get trapped by those kind of choice of words. So then people, it just doesn't make sense if you see it from their point of view. You know, oh gee, it got colder. What happened? And yet, if we look at it in terms of large-scale modeling, it makes sense. You know, we had a discussion yesterday about the number and severity of storms. That also doesn't make sense in a very, sort of an average perspective. It does make sense when you start looking at nonlinear coupling of events and loading.
If I could just add to it, I'm old enough to remember when as a teacher, I was teaching of the coming ice age.